So we had a lab in class involving how to get the pH of a variety of liquids. You could do this a number of ways. You could do this using a pH electrode and just simply dip the pH electrode into the solution and read the numbers off the screen. But one kind of older way is to use chemical indicators. Now they have a lot of chemical indicators out there, one of which, not the least of which, would be the universal indicator, where each color corresponds to pH. So that's an easy way to do it as well. Indicators, acid-base indicators, are a special class of chemicals that change colors depending on what pH they are exposed to. And universal indicators, a very nice one, and actually changes color to often depending on what the pH is, and you can get down to a single number or so. There's also a long list of other indicators that have a color change at different pHs. And so here is methyl red changing from yellow to red, and has kind of a pinkish orange in the middle near 5 or 6. Bromoethyl blue is a very popular one. It's yellow if it's less than 7 or acidic, blue if it's more than 7 or basic, and green if it's right at 7. And so right away with some bromoethyl blue you can get an idea if your solution is acidic or basic. What we're going to do is take a sample, and for the screencast we're just going to use a generic example. In lab you're going to use quite a few other chemicals. Take 3 to 5 drops of the chemical, take 1 to 2 drops of the indicator, mix them, record the color, and then what I like about this lab is the thinking that happens afterwards, where you're going to take your data, which is going to look like this: blue, blue, yellow, yellow, red, pink, colorless, purple. Take your data and try to figure out what the pH is. And so we're going to walk through the example together using this data. So the example is just an example, but it has a pH, and this data will tell us what that pH is. Now first you have to start with what are your possible pHs, and that would be 0 to 14. And so we write down this number line. So those are our possibilities. Now you could have a negative pH and you could have a pH above 14 as well, but for the sake of simplicity, 0 to 14. And so how does this blue color help us? What we have to do is eliminate options, and that's what these colors tell us what the pH is, and the colors that they are not tell us what the pH is not. So for example, bromoethyl being blue. So you look at the colors. Here's bromoethyl blue. It is blue, and so that means the pH should be probably 8 or above to be blue. That means it is not green and not yellow. So these colors are associated with numbers. So not yellow, not green gets us to cross out about 0 to 7 or so. On the very borders you want some leniency, so what I'm going to do is cross out 0 to 6, this line here being the yellow. So because it is blue, I'm going to cross out not blue, which is yellow and green, which is roughly 0 to 6. So I know these numbers are not possible. Still leave 7 through 14 as possibilities, but it crosses out 0 to 6. You cross out what it's not. You cross out what it's not. And so we took care of bromoethyl blue. Looking at bromophenol blue, it's blue. The data says it's blue. The indicator sheet says it's blue from roughly 4 and up, so that means it's not blue from 4 and down. Again, be lenient with the very edges of what you cross out, but we know it's not yellow, so we're going to cross out 0 to 3. It is blue, it is not yellow, so I'm correlating yellow to 0 to 3, so it is not 0 to 3. And this might seem repetitive, and it is, but scientists do like to reaffirm data. You may find in your lab that some of your data was bad data, whether you cross-contamination, bad colors, misread the colors. One bad drop could do it for you. So we like the fact that we have some repetition. So now we are doubly assured that the pH of our example unknown is not 0 to 3. So I'm going to do it again. Alizarin yellow is yellow, and so that is yellow for a pretty broad range, from 0 to 10 or so. And so we know that it is between 0 and 10, which allows me to cross out the orange and the red, and so that's roughly 11 to 14. The data says it's yellow, so that means it is not red, and red means 11 to 14. So I can cross out 11 to 14. So now I have kind of an idea it's between 7 and 10. We'll keep going through our data, put a little check mark there. Methyl orange is yellow, and so I go to my sheet. Methyl orange is yellow, and so that tells me it should be 5 and above. It should not be 4 and below. So we'll cross out 0 to 4 again. Now I'm triply sure that 0 to 4 is not true, and again that helps us just give us some more certainty to our conclusions. Phenolphthalein is pink, so let's look at phenolphthalein. It is pink, which happens roughly at 8 or so, because it is very stark pH change and color change, going from colorless to colored. And so 0 to 7 is colorless, 0 to 8 is colorless as well. It doesn't start getting pink until afterwards. So I can cross out that 0 to 8 part. So now I'm quadruply sure of 0 through 3, triple sure of 4, sure that 4 is not, doubly sure that 5 and 6 are gone, and now I have some data to kick out 7 and 8. Thymolphthalein is colorless, so what does that do for us? Here's thymolphthalein, colorless. Now we're up a bit higher. Now it tells me that 0 to 9 is possible. So this double crosses out 8. If you were uncertain about 8 and didn't want to cross it out, that's okay. The thymolphthalein crosses 8 out for us. But because thymolphthalein is colorless, it means it's not blue. And so blue happens 10 and above. And so now I go back over here and I cross out 10 and above. So now I'm doubly sure that 11 through 14 is not possible. Singly sure about 10, 7, 8, 9, 7 and 8, and 9 is still left over. So that's probably my pH. I'm going to check again with thymol blue, see if that gives us any more data. Here's thymol blue. The color is purple. So thymol blue is purple from 9 and up, maybe a little bit of 8 and up, but it is not yellow and it's not red, so I can cross out at the very least 0 through 7 again. I'm going to keep 8 in there. It's kind of on the border. You might argue you can cross it out, but like I said, you want to be lenient with what you cross out. You don't want to cross things out unless you actually know it not to be true. So you can cross out 8 if you want to. A bit safer to bet would be 0 to 7. So I want to cross out 0 to 7. And so now I'm doubly sure about 7. 8 and 10 were only crossed out once, but 9 wasn't crossed out at all. And so I would argue that my pH is 9. Perhaps you can have a range of 8 to 10. But without a digital pH meter, this is fairly good consistency, pretty good precision. At least we know it's basic. Then it's just a matter of how basic it is. It's not extremely basic in terms of being 10 or higher. You're going to fall someplace within this range. You can say the pH is 9. That would be my best guess according to my data. And 8 to 10 was only crossed out once each, so I'm not 100% sure I can cross out 8 and 10, but fairly certain, at least in terms of one piece of data crossing out 8, one piece of data crossing out 10. But 9 was never crossed out, so that is most likely our answer. So this is the logic that you're going to do for all of the problems. And again, you might end up with some bad data. Bleach tends to be a fun one to do because it actually reacts with the chemical indicators in a way that I hope you noticed when you did the lab. So you have to be mindful of what data you're crossing out. When in doubt, do not cross it out. And you might have some bad data that goes in the other direction. And so you have to be able to recognize what types of data you can kick out justifiably, not one that's just convenient, but one that you can justifiably kick out if you have disagreeing data. Is one supported more than the other, or it's one standalone? If it's a standalone type of data, then maybe you should cross it out. And when I say cross it out, I mean ignore that piece of data, accept it as bad data. Feel free to rerun the experiment. That's what a scientist would do. But a scientist would also look at the body of data and do the best to make inferences.